equation as well of a linear straight line. Equation of a straight line. And normally the question will say, write the equation in the form of y is equals to mx plus 6. The equation of a straight line. Y is equals to mx plus 6, or a linear line. Please be aware of that. But the information sheet assists us, because here is the information sheet. You can also consider it. There you have the equation of a linear line. There it is the equation again. You can see if you have a point, 1 point, and that point is x1, y1, you have 1 point. You also have the gradient. You have only these two, but you wanted to find the equation. There you are. x1, y1, you can use x1, y1, substitute them in there, and the gradient, then you write the gradient there. Then you will be able to simplify and find the equation of that line. So this becomes very, very important formula that you can use to answer questions that relate to these kind of concepts. But you see, with the equation of the lines, then you need to be aware of something. If you have, number one, I'll write here parallel lines. Parallel lines. If lines are parallel, then the gradient of one line is the same as the gradient of the other line. I wrote there M1 is equals to M2. Once you have parallel lines, then you know that what comes to my mind is, you know what, the gradient of this line will be the same as the gradient of the other line. And in this case, remember, we are given a trapezium in this example. And once we see the trapezium, these two gradients are equal. In fact, the two lines are parallel. And once the two lines are parallel, what do we know about the lines parallel? What do you know about the lines parallel? It means that the gradient of this line, I'll write it M1, will be the same as the gradient of that other line, M2. If you have the gradient of this line, then it means that same gradient will be the same gradient as the gradient of that other line. Now remember here, the question also, when you read it, said, is the midpoint of MP the midpoint? And once it says the midpoint, you already know from your formula sheet here, the expression for the formula for the midpoint. This is the value of x at the midpoint, and this is the value of y at the midpoint. If you like, you can write it as the value of x at the midpoint, x1 plus x2 over 2. This thing is the value of x, but where? At the midpoint, at the middle. And this one is the value of y, where? At the middle, at the midpoint. That's what this expression means. And it is there on the formula sheet. Good. So already once you have that kind of information assembled, when you come to this part, then all these questions relate to that kind of information. You just need to read the question carefully. Here is angle SPK is theta. Once you talk of angle, then you know that tangent theta is equals to m, the gradient. So this becomes very relevant. Once they say an angle is involved, then you know that somewhere, somehow, you must be ready to use that expression for the angle of inclination to answer all the related questions here. And as part of analytical geometry, you need to be aware, like we have here question, the next question. Normally the first question will relate to those concepts, but the other question that follows here, like the question here, it is question 4, I think. Now question 4 will demand of us to be having this necessary information that, you know what, like question 4 here. Question 4 mainly deals with the circle. The circle and its characteristics. Right? Question 4 deals with the circle and its characteristics. Look, once we have a circle, let me just say this is the Cartesian plane. Y and X. Once we have a circle, you know that the circle will have the center. Am I right? The circle will have the center, and at the center you still have the value of x and the value of y. And that being the case, you can still have the tangent on the circle. You see that line? It touches the circle at this point. And the tangent, when it meets the tangent, the radius when it meets the tangent, what happens? This is the radius. The line drawn from the center of the circle to a point on the circle. But now this radius, when it meets with the tangent, this angle formed here will be a 90-degree angle. The tangent is perpendicular to the radius at the point of contact. The tangent, when it comes to contact with the radius, will be perpendicular. It forms a 90-degree angle. Now you need to be aware of this kind of information. You realize that in this case, our center of the circle, which is any value there, the center or coordinates there, the center of the circle is anywhere and not at the origin. It is not here where 0 is 0 and 0. The value of x is 0 and the value of y is 0. But it is anywhere else. And what I like is the expression again is there on the formula sheet for the this kind of a circle squared, y minus b squared is equals to r squared. This expression also, it is for the circle, the equation of the circle, where the center is anywhere where you have the value of xa and the value of yb. This is the expression, and that expression you also still find it here on the formula sheet. They have it for us. Here it is. You don't have to struggle for it. When you come to this part of the question, there is the formula for the equation of a circle where the center of the circle is not at the origin, but it is at any point. That center, look at the center. The center of the circle is at any point. But keep in mind that the radius, once it comes into contact with the tangent, then the angle formed there is 90 degrees. And remember that the tangent is actually a linear line. The tangent is just the straight line that we have talked about in the first part of analytical geometry. The tangent is a straight line. And once the lines are perpendicular, you see now the radii and this tangent, they are perpendicular. Number 2 here we write, for perpendicular lines, the product of the two gradient must be -1. Perpendicular lines now, the first gradient multiplied by the second gradient, the product must be equals to -1 when the lines are perpendicular to each other. Keep that in mind. It's very important when you come to this part of the question. But for parallel lines, remember we said once we see lines are parallel, what comes to our mind is the first gradient will be the same as the other gradient because those two lines are parallel to each other. But for perpendicular lines, which are obvious from one of the theorems that we have learned in grade 11, the radius is perpendicular to the tangent at the point of contact. And once you are dealing with this part of the question, expect the perpendicular lines appearing there and know that, remember that the product of the gradients will be a -1, and be prepared to deal with this question. And this equation here, is for this circle, is for the circle where the center is at any point and not necessarily at the origin. But even if it's on the origin, it's fine because a is still 0, b is still 0, so you still have x squared plus y squared is equals to r squared because the center in that case will be at the origin. But here, the center is at the point A as well as the point B. Now, you know, the other thing that you need to be aware of, look here, the value of A must be a negative value, I don't know, maybe -2. The value of Y must be a negative value, maybe -3. Now, what happens when we substitute in here? When you substitute in here, be aware that this x minus how much is A? A is -2. Do you see what happens there? All squared plus. A is -2. So when you simplify, it becomes x plus 2 squared. Even though here it is -2 for A at the center, but in the equation now it becomes x plus 2 minus, and the other one becomes y plus 3 all squared is equal to r squared. Y here is -3, y is -3. So when you substitute -3 here, it becomes negative by negative, it gives you plus 3. Just be aware of that, right? I'm sure that covers generally what we know about analytical geometry. But be prepared, be very wide, read the question carefully, and see where you feature these concepts. These concepts will come into it will be expected of you to use them to answer the related questions in the question. The distance, the gradient, the midpoint we talked about, angle of inclination, which relate to the gradient. Look, tangent theta, that angle, tangent theta is equal to the gradient. The equation we have talked about, the lines, parallel, perpendicular lines, and mostly perpendicular lines. You'll find them here in this question because it deals with the circle and so forth. In the exemplar paper, we don't see a circle there. But read the questions. When you read the questions, you realize that the questions in them, they actually talk of the circle. It is not only there, the circle, but the questions relate to the circle. You just need to be aware which one is said to be the center, which one is said to be the point on the center, which one is said to be the point on the tangent, meaning that the line is touching the circle and so forth. Look, here is the equation. Can you see the equation? And this is the equation of what? Of the circle, where the point, the center is at anywhere, not necessarily at 0 and 0. And here we said if it is x plus 1, it means the value of x at the center is how much? Minus 1, and so forth and so forth. There we read, ABT is a tangent to the circle having the center N. So you see there's another circle there. There's a circle, and that circle has got a point N, 3 and 2. And that point N, 3 and 2. The circle has got a point here, maybe N is supposed to be here. 3 and 2, N, 3 and 2, the value of x. So it means this is a point on the circle. I mean there's a circle, I don't know, whatever way. Whatever, I'm not having that right. There's a circle. That diagram is not helping us at all. There's a point here, N is 3 and 2. Now, the question says, if you look at that question, ABT is a tangent to the circle having the center. The center of that circle is 3 and 2. So it means there is a circle somewhere there. You see that? This is the center of that circle. And ABT, the line ABT is a tangent. The line ABT, we have A, we have B, a point there. We also have a T here. ABT is tangent to the circle having the center that at the point T. The point T is this one here. You see that? Now, this diagram is not there in the question. But when you look at the question, there at T, you see there's a tangent. It means there's a circle here. There's a circle here. There is a circle here, and N is the center of that circle. It is not drawn, but you can draw your own circle here because they say T is a point on the circle and ABT is a tangent. Now we know that a tangent is a line that touches the circle only at a one point. Look at that question carefully, even though we don't see a circle, but when you read the statement will tell you what is happening. The tangent is a tangent because there's a circle. It's a line, straight line that touches the circle at only one point. Let's have a short break. And then 5 minutes, and then we come back, we look at the remaining part of the question paper, trigonometry as well as Euclidean geometry. Thank you very much.